Hello, this is Mr. Callahan making our first lesson video for Algebra 1. Most of the time I will make these videos while I'm teaching. And for that reason they're kind of long and they got to give students time to do the work that I'm asking them to do. As I'm doing this, I will not pause for the students to do work because I'm not doing it in front of the class. And if anybody's trying to follow along with what I'm doing here, you might want to pause the video when you're working on something and then set it to play when you're done. In Algebra 1, the first topic, first section, first chapter is going to be evaluate expressions. You can see the objective, which comes right from the SOLs. And it may not make much sense to you now. However, we'll review this same slide when we're done, and it'll make more sense to you then. Right, the number one most important concept in algebra, what makes it algebra and not arithmetic, is what? Variables. Right? A variable is an unknown quantity that's usually represented by a letter. In this case, I've written an example which says 4 plus x equals 6. So this is an equation that has an equal sign. And we recognize the 4 and we recognize the 6, and the x is our variable. And x is by far the most used letter for variables, but we use other letters for variables too, especially if it represents something real in the problem. Now, in this case, 4 plus x equals 6 is an equation that you could probably visually solve. What number would you put in the place of the x so that 4 plus x equals 6? And my guess is we are all going to jump on that and say x equals 2, which is correct. Now, examples of we are going to use variables in 3 different ways. In expressions, that's what we're dealing with today, equations, and functions. So an expression is something that looks like 4 plus x. An equation has an equal sign in it, like the last slide. A function has 2 variables in it. So, generally speaking, we try to solve equations. But we can't solve a function, not and get one value, because there's 2 different variables in the same equation. I could plug in a value, I could substitute a value for x and figure out what the y is, but then I would have more than one answer, and that is true. So we don't solve functions, we graph them. We figure out all the values that would make it true, and it leads to a graph. Now, what we do with expressions, well, first we're going to look at some expressions. Right? An algebraic expression is the same thing as saying a variable expression. And what makes it that is it's got a variable in it. You can see here's the, these are very simple expressions with just one operation going on in each one. The first one gives us 3 different ways to look at how we might multiply a number times a variable. Right? 5 parentheses n or 5 dot n. Both mean 5 times n. Usually we would write that with 5 right next to the n, and the multiplication is implied. 4 divided by y. 4 divided by y, we recognize. We should also know, because you're going to see this as much, probably more often than you'll see 4 divided by y, you're going to see it as a fraction. With the numerator is 14, and what you're dividing by is y. 6 plus c, 8 minus x, these are all variable expressions, right? They've got some arithmetic operations going on, but they've got a variable in them. Now, we're going to do 2 things with expressions, one of which we look at today, and that is evaluate. To evaluate an expression, we substitute a number for the variable, and we see what it equals. Evaluate the expression when n equals 3. This is an example coming from your book. The first one, 13 times n. Right? We recognize that dot meaning multiplication. Right? In order to evaluate means substitute the 3 for n, meaning in the place of the n, put a 3, which will look like that. Okay? And 13 times 3, you can figure that one out. 39. Here's another one. 9 in the numerator, n in the denominator. As we know, that means a divide. Substitute 3 for n. What will that look like? 9 over 3. 9 divided by 3, which is 3. Next. n minus 1, a subtraction. Evaluate for when n equals 3. 3 minus 1 is 2. And last, addition. n plus 8 equals. Evaluate for when n equals 3. 3 plus 8 equals 11. So the main thing you've got to get out of this, so first we know what a variable is. It's an unknown, usually represented by a letter. Next we know what an expression is, right? It is some combination of letters and numbers and arithmetic operations. And the next thing is, and this will come up even on tests, it'll say evaluate, and you're going to say, what does it mean to evaluate? That's what you're supposed to be learning from this, right? What does it mean to evaluate an expression? Okay, now I want you to try the same thing. And again, if you're watching this as a video, then you might want to pause right here. And when you're done, hit play, and we will go over this. These U-tries, I will check. I will check as you're doing them, and I will check at the end of class to make sure that you did all of them as we were doing the lesson. Okay, so again, if you're doing this at home on a video, this is the time when you want to hit pause. Okay, evaluate the expression when y equals 2. For the first one, 6 times 2 equals 12. Second, 8 divided by 2 equals 4. Third one, 2 plus 4 equals 6. And the last, 11 minus 2 equals 9. Okay, that's what you should have done. That's what you should have got. You should show your work when at all possible. Don't think of showing work like a weakness. It's actually a sign of strength. Okay. Now, if you understood that first U-try, you should give yourself a big check next to it. Because then when I'm coming around to check, I'm to look at your work later in class. I want to see which ones it seems like you got, which ones you didn't. So if you got it, give yourself a check. If you didn't get it, put a big X there so we can look at it. I will check on these U-tries at the end of class, and you're going to get a classwork credit. You could think of it as participation credit. It'll be counted with the homework category in your grade. So you don't want to not do these things. Okay, this is a word problem kind of example. The total cost of seeing a movie at a theater can be represented by the expression A plus R, where A is the cost of admission and R is the cost of refreshments. Suppose you pay $7.50 for admission and $7.25 for refreshments. Find the total cost. I'm showing this one for a couple of reasons. One is we got to look at these word problems. We can't shy away from word problems. That's where the real application of math happens. And even on one like this, that if you went to the movie theater, you'd be doing this in your head no matter what. Right? You'd be thinking, how much money do I need? But the other thing I kind of like about this problem, it shows you how sometimes we use letters other than X because they mean something to the problem. Sometimes it helps you to understand the problem to use meaningful letters. So in this case, we're using A for admission and R for refreshments. Find the total cost. Let's see what they did on this one. Solution. First they wrote an expression, right? The total cost will be A plus R, right? Then they substituted. They were evaluating essentially by substituting for A and for R. And of course, then we are simplifying. Total cost is $14.75. Okay, now we need to review. You should have had this somewhere in the past, but just in case you don't remember it or didn't get it, now you will. Because we'll use these words during this class, right? And we don't expect we're going to have to define them every time. Right? But when you see something like 3, normal size of a 3, and then it's got a 4, right, as to the upper right, and it's kind of a small 4, that is a power. And the 3 is what we call the base. The 4 is what's called the exponent. And what it's telling you to do is take the base and multiply it times itself 4 times. Right? That's what it means to have a power. In this case, 3 times 3 times 3 times 3. 4 times you multiply 3, and you see what that equals. Now, as we're going through these, the main thing is that you understand what it is to raise something to a power, to an exponent. If the simplification is too much, at least you can show that you understand what you're doing here. I mean, 3 times 3 times 3 times 3, we could definitely do that one. That's not too tough. That's 9 times 9, which is 81. But some of these may get a little more difficult. If you can't figure out the whole thing, at least you know, show that you understand how you're raising the base to the exponent. 7, let's go through these examples right here. 7 is the base, 1 is the exponent. You know, we would say 7 to the first power. In fact, most of the time, if you're raising something to the first power, you don't even write the 1. It's assumed you mean 1 if there's no exponent. Okay, 5, base of 5 raised to an exponent of 2 is 5 to the second power, also known as 5 squared, right? That's a word you need to know, and that is 5 times 5. 1/2 to the third power is also known as 1/2 cubed, which again would be 1/2 times 1/2 times 1/2. And then z to the 5th, you know, when you get above cubed, we're just going to say 4th power, 5th power, 6th power. We don't have a shorthand way of saying that. So z to the 5th power is z multiplied times itself 5 times. Okay, here's your second U try. Go ahead and try to do the same thing with this, right? Write out what does it mean to say 9 to the 5th power, or 2 to the 8th power, or n to the 4th power, right? If you're watching this at home, pause the video, and when you're done, hit play. Okay, 9 to the 5th. 9 to the 5th would be 9 times 9 times 9 times 9 times 9, right? 2 to the 8th. Ooh, that's going to take a lot of space. Let me write that down here. 2 times 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 2. Okay, do we have 8 2's? I think we do. Okay, n to the 4th. How many times do we need n to be a factor, meaning something multiplying times itself? And the answer is 4. N times n times n times n. Okay, again, if you got it, give yourself a check. If you didn't get it, give yourself an X. Okay, now we're going to evaluate some expressions that involve powers, right? X to the 4th. Evaluate x to the 4th when x equals 2. Okay, again, what does it mean to say evaluate? Right? It means substitute for the variable. In this case, in place of the x, put a 2. Okay, now you need to know what it is to raise 2 to the 4th power. And as you know, that means multiply 2 times itself 4 times. 2 times 2 times 2 times 2, which is 16. N to the 3rd. Evaluate n to the 3rd when n equals 1.5. Evaluate means substitute, so we substitute. Now, this might be an example of a computationally difficult problem for you to do, but at the very least you could, write it out. What does it mean to raise 1.5 to the 3rd power? It means multiply 1.5 times itself 3 times. Now, in class, we're not using calculators, at least at this point. If you're going to do this, you're going to do it by hand. If you're at home and you're using a calculator, which I can't stop what you're doing at home, then this would be a fairly simple calculation. I'm not even sure what they do with this one. Okay, they wrote it out, 3.375. I mean, how would I multiply? How would I multiply 1.5 times 1.5 times 1.5? Well, first I would multiply 2 of them. What is 1.5 times 1.5? Right, 5 times 5 is 25. 5 times 1 is 5, plus 2 is 7. Okay, put a 0 because you're multiplying with a 1, which is in the 2nd column. 1 times 5 is 5. 1 times 1 is 1. Okay. Oh, that was actually incorrect. And I should have known better than that. Okay, add them up. You're going to get 5, 2, 2. And now, because we had 2 decimal places to the, each one of those had a decimal place to the right of the decimal point. That's 2. I need to move this over 2. It doesn't line up like addition. Okay, now if I was going to do one more of these, I'd have to go 2.25 times 1.5. And I'm not going to go through all the calculation, but that is how they got 3.375. And notice they had 3 decimal places to the right. That's because there's 1, 2, 3. Okay. Here's your 3rd U-try. Go ahead and do these. Pause the video, and when you're done, hit play. Let's do the same thing. X to the 3rd, when x equals 8, is 8 to the 3rd, which is 8 times 8 times 8. Okay, if I was going to do the calculation, 8 times 8 is 64. So this is 64. That part I can do in my head because that's a math fact. Now, 8 times 64, you might have to do a little bit of work. Right, 8 times 4 is 32. 8 times 6 is 48, 51. 512. K squared when k equals 2.5. So that'll be 2.5 times 2.5. Right? If you got that far, you got the most of that problem. You got the most of the understanding that we're really going after here. So show your work, get partial credit. If I'm going to multiply 2.5 times 2.5, does anybody know what 25 times 25 is? You might. If you do, you'll say it's 625. We don't get 625 because we actually had 2.5 times 2.5. We need to move the decimal place over 1 and 2. So it's 6.25. And d to the 4th when d equals 1/3. Again, that will be, and I'm going to use parentheses. This is where you really need parentheses. 1/3 4 times. Right? Which is like this. When you multiply fractions, you just multiply straight across. Which is 1. I think we saw 3 to the 4th already. That was 81. So this is 1 over 81. Okay, now look at these two. These come from the homework section. We're not doing these problems in particular, but what do you see wrong here? I mean, the name of the section was error analysis, so obviously there's something wrong here. You know, this says 0.4 to the second power, right? The base is 0.4, the exponent is 2. Does that equal 2 times 0.4? Right? 2 times 0.4 is really like saying 0.4 plus 0.4. Is that what it really means to raise something to the second power? No, right? It should have been 0.4 times 0.4. That was the mistake. Okay, what's wrong here? 5 raised to the 4th power. Okay, here I see 4 5 times. Isn't that right? What's not right? Okay, remember, it's the base which is being multiplied times itself, not the exponent. So they've reversed the roles of the base and the exponent here. We don't want 4 5 times. We want 5 4 times. Oh. I'm sorry for my writing here, but I'm just getting used to this. Tablet and stylus and everything. So 5 times 5 times 5 times 5, 25 times 25 is 625. That should have been the right answer. And this one I didn't say what it was, but 4 times 4 is 16, but we would move over the decimal point, so it's 0.16. Okay, so this was our objective at the beginning of the lesson, to evaluate expressions. Evaluate algebraic expressions for a given replacement set to include rational numbers. And I would say that at this point, we understand algebraic expressions and we understand what it means to evaluate them. Now, we may not use the words replacement set or rational numbers, but that's the wording of the SOL. We were replacing the variable with a value. That was the replacement set. And rational numbers just mean fractions, and we definitely did substitute fractions. So that was the lesson. That was our objective. Again, I'm going to go around and check on all of your U-tries, so please have that out. I want to see who got it and who didn't get it and who I can help with. And actually, I'm saying this as I'm recording this video like I'm doing it in class, but that would be part of the class. The homework is from page 5. 3 through 13, 27 to 37. When I say odds, I mean for both groups. Odd numbers from both groups of problems. Now remember, you have odd number problems answered in the back of the book. So you should look there. I'm going to check this at the beginning of next class. To be checked for effort, for completion. You got to be trying this stuff. I mean, I'll be fairly generous, especially this first time, but you have to be trying this stuff. You know, learning math doesn't stop when you leave this door. So remember that you can go to there are a couple resources that you've got here. One of them is the textbook website. Which is classzone.com, and then there's another one which is Hot Math, which is tutoring. Which I would go to this one through the family portal on the York County website, because and if you go through it that way, you're automatically logged in because York County has paid for this. So in any case, that's our first lesson. We'll get better at this as we go along.